This recording is a solutions recording for the fourth and final pre-cal review at the beginning of the year. We're working on page 241, numbers 1 through 7 odd, numbers 9 through 28 all, and my purpose here is just to work this whole thing, so if you have a question and need a lengthy explanation, you have an opportunity to have that because class time may be too short for all the questions that we have. Number 1, these all have actually multiple parts, so I'll do them all here. Part A wants to find the distance from P to Q. Part B is the midpoint of PQ. And part C is the equation of the line. And they want it in slope-intercept form if possible, so y equals mx plus b if possible. The first problem we have, we're given that P is 3, 5, and point Q is 2, negative 3. So this is just the beginning practice of it. I would like to point out that the distance is best remembered by considering it as part of the Pythagorean theorem. So these are the 2 points that I want to find the distance between. If I draw a line between them, squint and pretend like that's a good line, then we can also think of it like a right triangle, where I have a vertical line and a horizontal line. If I travel, let's make the horizontal line pink, if I travel from an x value of 2 to an x value of 3, that's a length of 1. If I travel from an x value of negative 3 to an y value of negative 3 to a y value of positive 5, that's a distance of 8. So the distance formula, if you actually used the official distance formula, it says it's the square root of x2 minus x1 squared plus y2 minus y1 squared, and take the square root of all of that. I like to think of the distance using the Pythagorean theorem. I know that the distance squared is equal to 1 squared plus 8 squared, and of course 1 plus 64 is 65, and if d squared, this is d, the distance I'm looking for, if d squared is 65, then d is just the square root of 65. Now if you fill all of that in here, what you find out is x2 minus x1 is simply this distance. It's 3 minus 2. When you square it, it doesn't matter which one you start with. 2 minus 1 squared, 2 minus 3, 3 minus 2, same thing. Then the y value that you get is the distance from negative 3 to 5. And again, it doesn't matter if you say 5 minus a negative 3 or negative 3 minus 5. Since you're going to square it, both of those give you 8 squared or 64. So I like to think of it just as how far apart are these two, square the values and take the square root of the answer, rather than necessarily remembering the distance formula. But that's my personal preference. You can do it either way. It's not a big deal. To me, the fewer formulas I have to memorize, the better off I am. All right, so then the second part of this question, part B, and again for number 1, I have P is 3, 5, and I have that Q is 2, negative 3. The midpoint is exactly halfway between them. So think of the midpoint as being the average x value and the average y value. So the x values are 3 and 2. To find an average, I add together, divide by 2. The y values are 5 and negative 3. If I add them together and divide by 2, that's an average. 5 over 2 for the x value, 2 over 2 for the y value, or, probably most simply put, 5 over 2 and 1. So that's the distance, I'm sorry, that's the midpoint between them. And when you think of midpoint, if you'll just think of the average of each of them, remember that average means you add the numbers together, divide by 2. It's a very simple process. Just trying to think of ways to help you remember which formula to use and which one it all means. In C, we're asked to write the equation of the line. When I find the equation of the line, I always do it the same way. The first thing I do is find the slope, and the slope is the change of y, and really we already did that, right? The difference between them, they're 8 apart, and the x value is 1 apart. So back in problem part A, when we found the distance from P to Q, we found those distances, right? So it rises 8 as it runs 1, so the slope is 8. So my first step to find an equation of a line is always to find the slope. My second step is that I use the equation y equals mx plus b, and I try to find b simply by using a y, an x, and an m that I'm given. It doesn't matter which y and x I use as long as it's 1 point. So I'll just pick the 3 and 5 because it doesn't have a negative, and that's convenient. So y is equal to m times x plus b. That means that y is 24 plus b. If I subtract 24 from both sides, I get that b is a negative 19. And so, if that's true, then the equation of the line is equal to y is mx plus b. The third step is you actually write it, and you fill in the b value that we found, you fill in the slope that we found, right? So you use the slope here, you use one of the points, and if you did it again using 2, -3 for your x and y value, you'd get the same answer. So that is the equation of the line. All right, so now we're going to do the exact same process with number 3. It never hurts to get an idea of what the line looks like as you start. So a -2, +2, this is the point P. A +3, +2, this is the point Q. When I draw the line, it occurs to me that this is a horizontal line, and I know it's horizontal because my y values are the same. It's a flat line. So it makes everything easy, right? The distance, I don't have to use a Pythagorean theorem or right triangle or anything. I just know if I'm going from a -2 to a +3, that distance is a distance of 5. If the line is 5 long, the midpoint is going to be halfway between them. So from a -2 to 3, if I go up 2.5 or back 2.5 from either point, I'm at 0.52, maybe call it 0.5 just to make sure it's clear. That's a distance of 2.5 from either endpoint. Part C, the equation of the line, a line that is horizontal, has a slope of 0. The y-intercept, of course, is 2. It touches, right? I know the y-intercept is 2 because it touches at y equals 2. And so that is actually the equation of the line. Every point on that line has one characteristic the same, and that is the y value is equal to 2. So hooray for easy problems. Number 5 is the other special case. P is 5, -1. Q is 5, +1. Here's the line we're looking at. Part A, the distance from P to Q is 2. Since it's right along the line, the distance is just 2. Part B, the midpoint is going to be 5, 0. Halfway between -1 and +1 is 0. Part C, the equation of this line is x equals 5. Every point on this line has one characteristic in common. It is that x is equal to 5. This, for this kind of a line, we say the slope is undefined. There is no y value. We don't have y equals anything, but every value on this is x equals 5, so we'll leave it at that for the answer. Let's look at number 7. This one looks a little harder to graph, except when you notice that both of the y values are exactly the same. So the nice thing about this graph is, I don't know what 2 root 3 is, but I'm just going to label it. And if this is 2 root 3, and this is 6 root 3, and this height is 3 root 5 for both of them, then I already know a lot of information about that. First, the distance between them is simply 6 root 3 minus 2 root 3. I like to think of this as a blue blob. I have 6 blue blobs. I take away 2 blue blobs. What I have left is 4 blue blobs. Think of the root of 3 as a blue blob, right? I have 6 of them minus 2 of them, so I have 4 of them. 4 root 3 is the distance between the 2 points. Part B, I'm asked to find the midpoint. Well, halfway between 2 and 6 is 4, so 4 root 3 is the midpoint. You could certainly add them together and divide by 2. 2 root 3 plus 6 root 3 divided by 2 is 8 root 3 over 2, which is 4 root 3, which is what we said it was going to be. And then the last question on this one is to find the equation of the line. Every y value in this problem is 3 root 5, so the equation is simply y equals 3 square root 5. Okay, so that is the solution to numbers 1 through 7. So let's keep going and look at number 9. We're going to do some practice of writing equations of a line, and then we're going to sketch the graph. If a line goes through this point, these 2 points, as I said on, I think, problem number 1, we did this, so if you want to go back and look at it, to write the equation of the line, I do it in the same 3 steps every time. The first thing I do is find the slope. The definition of slope is the difference of the y values over the difference of the x values. How far apart are they? When I look at these, I don't have to do a lot of convoluted math. From 1 to -1 has a distance. Okay, we're going to do the math just so we make sure we get the signs right. But 1 subtract -1 is 2, because 1 plus 1 is 2. Now I'm going to do the x values, and that's a -2 minus 4, which is a -6. And so the slope, when I reduce that, will be a -1/3. The second thing I do is to use one xy point, it doesn't matter which one, and the slope to fill in y equals mx plus b. Doesn't matter which one I use, I'll just use the first one for my y and my x value. Of course, I already know that my slope value has been found, and what this will allow me to do is solve for b. So my y value is 1, because I picked this point to use. My slope is a -1/3. The x value is a -2 plus b. Notice the only variable I have is b. That's what I'm solving for. So 1 is equal to 2/3 plus b. If I subtract 2/3 from both sides, I'll get that b is equal to a +1/3. Think of this as 3/3 minus 2/3 is 1/3. So the equation of the line, the third thing I do is write it in by filling in m and b. So y equals m, -1/3 x, plus b, 1/3. Every time I do it, I'm just simply using that format. I do it the same way every time, and then it asks me to graph the line, and so I don't mind at all if you sketch it. Here's 2, 1, 4, -1, and there's a sketch. it doesn't hurt to make sure things work. This line is going down and my slope is negative, so that matches up with what I expect. Ah, look, good thing I checked. The y-intercept is supposed to be 1/3. No way do I have 1/3. What did I do wrong? Well, I did not pay attention to this negative sign, so I think I start over. Now this graph also is going in the negative direction, but this graph is much more believable if you tell me the y-intercept is 1/3. So, good thing I checked. Turns out I have the right answer now. I wouldn't have had if I didn't check my work. Number 10. This one, I want to find the equation for the line that's a horizontal line through the point 2, 3. That's this point. So a horizontal line looks like this. That's my sketch of the graph, and my equation is every point on this line, this point is 2, 3, this point is 0, 3, this point is 18, 3, or whatever. Every point on this line has the equation, the value of y equals 3, so that's the equation of the line. Don't make it any harder than that. Number 11. This problem asks you to write the equation for the circle that has a center at 2, -1 and a radius of 3. And I put on the right side page the thing you have to remember. If you have a value of hk as the center, then h and k go into this equation. Notice the minus signs are part of the equation. So hx minus h plus y minus k, each of those are squared. And it's set equal to the value of the radius squared. So in this equation, the h value is the x value of the center, so that's 2. The k value is a -1, so y minus -1 is y plus 1 squared, and it's equal to the radius squared. 3 squared is 9. That's the equation of the circle that they're looking for, and you can leave it just exactly like that. Number 12. This problem tells us that we have a circle with a center of 0, 2, and it's tangent to the x-axis. Now my circle drawing skills are really limited, but here's the point. If it's tangent to the x-axis, it goes down and touches it, but does not go through it. That means that the distance from the center to the outside edge of the circle is 2. If I drew the whole circle, something like that, but again, the point is, all I need to know to write the equation of the circle is the x and y value of the center in the radius. So in this case, it's x minus 0 squared, or just call it x squared, plus y minus 2 squared equals 4. And it doesn't matter if you left it in this format. That's okay too. Just don't forget to square the radius. The radius is 2. We know that because the center is a distance of 2 away from one of the outside edges, since it's tangent to the x-axis. Number 13, we have a line that goes through 3, -5 and has a slope of a -5/6. Remember my 3 steps to writing the equation of a line? We talked about it earlier. It's in number 1. It's also in number 9, so if you need more information, go back and look at those recordings, problem number 1, problem number 9. The first thing I do is to find the slope, which in this case is given to me. That was convenient. The second thing I do is use y equals mx plus b and use an x and a y value. In this case, I'm only given 1, so I have an x and a y value. Use the slope that I found in part 1, and I can then solve for b. So in this case, I have a negative 5 is equal to 3, no, that's not true, to negative 5 over 6 times 3 plus the value of b. That's what I'm looking for. When I multiply this, cancel the 6 and the 3 and leaves me with a 2. So I have a negative 5 is equal to a negative 5 over 2 plus b. I'm going to add 5 halves to both sides. It'll be most convenient to think of this as a negative 10 over 2, so I can combine my fractions, and that will give me that b is equal to a negative 5 over 2. The third step is simply write the answer. I have m, I now have b, and so all I have to do is write y equals m x plus b. Since b is a negative 5 halves, I can just write negative 5 6x minus 5 halves, and that's the equation of the line for number 13. It asked me to graph that, and the easiest way to graph it, actually, make a little room over here, is simply to take 3 negative 5. If the slope is a negative 5 over 6, that means if I rise 5, which puts me right there, and I run 6, and notice I went a positive 5 and a negative 6. I could have gone a negative 5 and a positive 6, but that would have been down 5 and over 6, which would have been way over here somewhere. This is a little bit easier to draw, and by the way, this point is a negative 3 in the x direction, a 0 in the y direction, and all I have to do is graph the 2 lines, 2 points, so that it makes one line. And so my graph would show, and we would list it, that I have a point at negative 3, 0, 3, negative 5. That gives me a slope of a negative 5/6. If I look at it, I see the line goes down. That's a good thing to notice. Number 14, I want a line that goes through the origin. So 0, 0 is on the line, and it's perpendicular to the line 3x minus 4y is equal to 2. Two things that you need to know about algebra in order to do this problem. One is the fact, this is a fact, it's true all the time, perpendicular lines have slopes that have two characteristics. One, the slopes have the opposite sign. Second, the slopes are a reciprocal fraction. So if line 1, the slope of the first line is 3/5, the slope of the perpendicular line will be a negative 5/3. Okay, that's just always true. You know about perpendicular lines, they will have the opposite sign, because remember, if one's going up, the other one has to go down to be perpendicular, and the value of the slope will be the reciprocal. So then, the second thing you have to know is that if ax plus by equals c, that you could solve for the slope by getting y by itself. This is kind of just a two-step proof. You could subtract ax from both sides. By is equal to a negative ax plus c. Divide both sides by b. And the number here in front of the x value is your slope. So what that tells me is a negative a over b is the slope. And that means I can always find the slope of a line that's in ax plus by equals c form by taking the opposite of a over b. Now if you don't remember that, no big deal, you can always just put it in slope-intercept form. But here's the point. If my first step of finding the slope of a line, or finding the equation of a line, is to find the slope. In this case, I'm going to find the slope by saying the slope of the perpendicular line is a negative a over b, so a negative 3 over a negative 4. So that's the slope of this line. So my line that I want to find the slope of is the opposite sign and the reciprocal. So the slope of this line is 3/4. The slope of the line I'm finding, I call my line, is a -4/3. The second thing we do is put it into y equals mx plus b. I'm going to use a 0 for y and a 0 for x. Well, I guess that's kind of silly, isn't it? Because we knew the y-intercept was 0. This is the y-intercept. If it goes through the origin, the y-intercept is 0, which I just proved. 0 is equal to b. That was good to do all that work for nothing. So then the last step is to simply write the equation out. If y equals mx plus b, if the slope is a -4/3 and the y-intercept is 0, then y equals -4/3 x is the equation for the line on number 14. Number 15, we say the line through -3, 2, and we want it to be parallel to the line 2x plus 3y is equal to 6. Again, now one more fact to know. Parallel lines have equal slopes. So how do you write an equation of a line? Number 1, find the slope. 2x plus 3y equals 6. The slope is a -a over b. We talked about that on the last page, where a is 2 and b is 3. So if the slope of this line is -2/3, then the slope of our line is a -2/3 as well, because parallel lines will always have the same slope. The second step is to take y equals mx plus b and fill in y and x from a known point, fill in the slope, and find b. So 2 is equal to -2/3 x plus b. They made the math really nice and easy for us here. 2 is equal to a +2 plus b. b is equal to 0. So in this problem, it crosses the origin at 0, 0 as well. And now we're just going to write our equation. Y equals -2/3 x. You could put a +0 there if you want to. You wouldn't have to put a +0 there, but that's the equation for the line on number 15. Number 16, if we want a vertical line through -4, 3, if it's a vertical line, what a vertical line has in common is that all of your x values are the same. X equals -4. Now I have not been drawing graphs for each of these, but given a point and a slope, I think you could find the graph of any of these lines. We can talk about that in class if we need to. Number 17. We're supposed to use this equation and decide whether it has an equation, has a circle as its graph, and if it does, we're supposed to give the center and the radius. The way to take an equation like this and change it into a circle, and this is something you may or may not have seen as much in your Algebra 2 class. It's not hard. You've done the bits and pieces, you just may not have put it together into one problem. So, but it's very basic, really. I need to find my x values and put them in the form of a square. So I'm going to use those. I need to take my y values and put them in the form of a square. And then everything else on the other side of the equation will be my r squared. So I have an equation. Currently they're balanced. X squared minus 4x. If you remember the idea of completing the square, how do you complete the square? It's one of the ways you could solve a quadratic equation, but the idea is you take the b value, okay, given ax squared plus bx, Okay, take this b value, and there's not going to be a plus c, but take the b value, divide it by 2, and square it, and that's going to be the c value that you're going to want to have. So in this case, I have a negative 4. I'm going to divide it by 2 and square it. That's going to be a negative 2 squared, which is 4. So I'm going to put a plus 4 here because by picking my very special value of c, I now have x minus 2 squared. If you factor that, that is a quadratic expression that has the factored answer of x minus 2 squared. But remember, currently I have it's equal to 4, but because it's balanced, I just added 4. I need to add 4 to the right side to keep the balance going. Then I have y squared plus 2y. I'm going to do the same process here. My b value is 2. I'm going to divide it by 2 and square it. That's 1 squared, or 1. So I'm going to add 1 to this one and add 1 to this one. Again, the whole point here is if I complete the square correctly, I'll have a perfect square. On the right side, 4 plus 4 plus 1 is 9. So the question is, determine whether it's a circle. Yes, it is. How do I know? Because it fits the formula for a circle. And if it is, give the center and the radius. Remember, the subtraction sign goes with the equation. So x minus 2 means I'm subtracting 2. Y plus 1 is the same thing as y minus a negative 1. So the y value of the center is a negative 1. That's the center. The radius squared is 9, so the radius is equal to 3. Now, I'm confident that in an Algebra 2 class you would have learned to complete the square, whether you've put it together with your equation of the circle, how much you talked about the equation of the circle. Some of those are a little more iffy, but at the very least, and we actually will cover this again actually soon in Chapter 9, because we'll skip to Chapter 9 pretty quick here. And so don't worry too much if this is not crystal clear, but the idea ought to be good. And once you're given the equation of a circle like this, manipulating the numbers on the left side of the page ought to be pretty much okay to do. What about number 18? X squared plus 6x, or the x portion, plus y squared plus 10y equals 36. I'm going to complete the square with the x's. X squared plus 6x, 6 divided by 2 squared is 3 squared is 9, plus 9, and I'm going to have my 36 plus 9 on the right side. Again, I have to add the same thing to both sides, so since I added the 9 on this side, I have to add 9 on this side of the equal sign to keep them balanced. For the y values, 10 divided by 2 is 5, squared is 25. So I'm going to add 25 to both sides. Don't really need that parentheses. Since I have now completed my square, I have x plus 3 squared plus y plus 5 squared is equal to 50, 61, and 9 is 70. So the center of this one I'm sorry, actually I think I wrote it down wrong. Oops, hold on a second. Starting thing is to always write down the problem correctly. When I have this problem, plus 36, then when I try to set it in the right format, I put a negative 36 over here, and instead of 70, I get a negative 36 plus 34, and so this is equal to a negative 2. And that's kind of the key. to this problem. This one is actually not a circle, and the reason is because the radius squared cannot be a -2. That clues me in that this equation will not make a circle. Now right now, you're not being asked what does it make, you're just being asked is it a circle or not, and the answer is no, it is not a circle. The reason is because the radius squared cannot be a -2. Number 19. Continuing with this, it's practicing the same thing. X squared minus 12x plus 36. If you need more explanation, 17 and 18 are on here, but we're going to do 12 divided by 2 squared. 6 squared is 36. I'm going to add it to both sides. Y squared plus 20y. No, it's not y squared plus 20y, it's just y squared plus 20. So I think the important thing here, okay, first off I'm going to move the 20 to the other side. And I'm going to add 36 to both sides. Y squared can be written as y minus 0 squared. So it looks funny, but sometimes I like to say it's so easy it's hard, right? Y squared is the same thing as y minus 0 squared, of course, but in this form it's easy to see that the center is 6, 0, and the radius is 4. Several problems on completing the square here, just to make sure you have time to understand the process. Again, each time I'm going to take half of that value and square it and add that to both sides. You have to keep your equation balanced. So I pulled this one sort of out of clear blue sky and I add it there because that gives me x plus 1 squared. The y squared plus 16y, 16 divided by 2 is 8, squared is 64. So when I add 64 to both sides, and this one becomes y plus 8 squared, and this will give me a positive 4. So my center, again remember the equation is that x minus the center and y minus the center, so effectively it's always the opposite sign of whatever's inside, and the radius is the square root of that number. Radius squared is 4, so the radius is 2. Number 21, x squared minus 2x plus y squared plus 10 equals 0. X squared minus 2x, the 2 divided by 2 squared is 1. Bring the 10 over, add 1. The problem is the y is already squared, and so I end up with x minus 1 squared plus y minus 0 squared equals a -9. And this -9 is what tells me I have a problem, because the formula tells me that the radius squared is that number, and that cannot be, so this is not an equation of a circle. Number 22, x squared plus y squared minus 8y minus 9 equals 0. Move the 9 over. Complete the square with the y. 8 divided by 2 is 4. 4 squared is 16. I'm going to add 16 to both sides, and now I can have it in standard form. X minus 0 squared, y minus 4 squared equals 25. So the center of this circle is 0, 4. The radius is equal to 5. And that's the information I know about this equation. All right, number 23 through 28 have several questions each. You're supposed to find the domain and find the range. Part B, if it's a function, rewrite as f of x, and then find f of negative 2. And so number 23 is 3x minus 2y is equal to 1. When you look at this equation, you should know that it's a linear equation. How do you know that? This is linear because it's in the form of ax plus by is equal to c. That's the standard form of a linear equation, one of them. The other, of course, is y equals mx plus b. It's a linear equation. It draws the graph of a line. So any line, no matter what line it is, when you graph it, remember the domain are the x values, the range are the y values, and a line, if it's just a regular line, will be, the domain will be from negative infinity to infinity, and the range will also be from negative infinity to infinity. The x values start at negative infinity and go all the way across. The y values are all the way from negative infinity to positive infinity. So the domain and range are negative infinity to infinity. Now it does graph a function. What's a function? Remember, a function has one requirement. It has to pass the vertical line test. So if you draw a vertical line through the function, it has to cross exactly one, no more than once. Cannot hit twice. So a line is a function, but a curve like this would not be a function because when I draw my vertical line, it touches twice. So if it's defined, if the equation defines a function, yes it does, it's a line. The line is going to pass the vertical line test unless it's a vertical line. So if it's a function, they want us to write it as f of x format, and then find f of negative 2. Here's another thing to learn and remember. F of x is a nickname for y. So if I take 3x minus 2y equals 1, and I subtract 3x from both sides, and I divide both sides by 2, I could do it like that. I could make it two separate fractions if I want to. Then to write it in function notation, I just take away that y and make it f of x equals, because y and f of x are nicknames. If you then want to find f of negative 2, it means you're going to put a negative 2 in for x. So negative 3 times negative 2 plus 1 over negative 2. That's the same thing as a positive 6 plus 1 over negative 2, which is a negative 7 halves. So the value of the function is this. The value of f of negative 2 is a negative 7 halves, and that's the solution for number 23. Oops. Actually, I wasn't going to turn the page. I was just going to do it all here because I've got the instructions over there. Number 24 is the equation y plus 3x squared equals a negative 1. Let's talk about the domain of this function. This is a little tricky sometimes. Domain and range is more logical than math, and so you have to think. Domain is the possible x values. Can I put, is there any limit? Am I limited to what I can put in for x? And the answer is no, I'm really not. X could be negative, x could be positive. Whatever I put in works just fine. Okay, anything works for x, so the domain is going to be from negative infinity to infinity. Now the range is an interesting one because think of it this way. When I take a number and I square it, there's a limit on the value of x squared. Now x can be anything. It could be negative 50, it could be positive 75, it could be 0, it could be anything. But my value when I square it is going to be from 0 to infinity. So this number might be as small as 0, but it will be no smaller than 0. So y could be a negative 1, but as this number grows, y will be bigger, but y will never be smaller than a negative 1 because it's limited. That 3x squared is limited in its size by being as small as 0. Okay, so think about this a second. If y plus 3 times 0 squared is negative 1, then of course that tells us that y is equal to negative 1. If I make x be equal to a positive 1, then I get y plus 3 is a negative 1, and y is a negative 4. So actually my intuition a while ago was a little bit backwards. Actually that negative 1 is a maximum value for y. When x is 1, y is a negative 4. I'm going to erase the work and keep doing those kind of problems. What if I let y be equal to, what if I let x be equal to a negative 5? Well, that tells me that y plus 25 times 3 is 75 is equal to a negative 1, which means y is equal to a negative 76. At my limit point, the smallest I can possibly have this value is to be equal to 0. At that limiting point, the value of y is a negative 1. Everywhere else, if x is positive, if x is negative, everywhere else, y is smaller than that. So my range, my possible y values, have to include the fact that y goes from negative infinity as high as negative 1. It can be negative 1, but it will never be smaller than negative 1. So we put a bracket on the negative 1. That's domain and range. Then it wants us to find the f of x. Well, if I want to solve for y, I do this, subtract from this equation, right? I subtract 3x squared from both sides and come up with that. And remember, y is just a nickname for f of x. So I can literally just say, instead of y equals, I can say f of x equals. And if I want to put in a negative 2, f of negative 2 means wherever I have an x, I'm going to put a negative 2. Remember that a negative 2 times a negative 2 is a positive 4. And then a positive 4 times a negative 3 is a negative 12. Minus 1 is a negative 13. So f of negative 2 is negative 13. Let's look at number 25. X minus 4y equals negative 6. This is an equation of a line. Every line that you draw, except for horizontal and vertical lines, and this is certainly not a horizontal or vertical line, right? A horizontal line is when you always have the same y value. A vertical line is when you always have the same x value. A vertical line is not a function. By definition, it is a vertical line, so it doesn't pass the vertical line test, right? The horizontal line is a function because it passes the vertical line test, but it was going to have a different domain and range if you think about that. But this one's a line with a regular domain and range. The domain is going to be from negative infinity to infinity. The range is going to be from negative infinity to infinity. The idea here is any line that you draw, the further you go on the x, it's always going to have a matching value. If you go x all the way to positive, it's going to have a matching value. Wherever you are on the y-axis, it's always going to have a matching value. Every value on the x and y is going to have a matching spot. So it doesn't matter what you have, the domain and range will always go to infinity in both directions. If I want to write it as f of x, I just have to solve for y. I think I'm going to move the 6 over here and the 4y over there. That gives me y is equal to x plus 6 over 4. And instead of y, I'm going to use its other nickname and just call it f of x. Okay? Some people call me Mrs. Barnett, some people call me Mom, some people call me Brenda. It's a nickname, it's the same thing, you can substitute it in. Okay? And then f of negative 2 is what we're asked to find. A negative 2 plus 6 over 4 is equal to 4 over 4, which is equal to 1. Nope, I keep trying to turn the page. I keep thinking I'm going to use the same page because the information is over there. Not a lot of information, but it's there. Number 26, y squared minus x equals 5. Now, y squared minus x equals 5, let's talk about the domain and the range of this function. Here's where we get into problems with this one. The y value can be anything. I can put anything in there and square it, and that's fine. But here's the problem with this one. If I solve for y squared equals x plus 5, what I know is that because I squared it, and that's where you get into things you have to consider. When you square it, the smallest this could be is 0. If 0 is less than or equal to x plus 5, then x is greater than or equal to 5. Subtract 5 from both sides. So what that tells me is my domain has to be greater than or equal to 5. So 5 is the smallest one. Remember, parentheses means it's a limit, it's a boundary. 5 means it's included. So the domain goes from 5 to infinity. Y squared minus x equals 5. My domain is going to start at 5 and go to infinity because I can't put, right? Look at what happens here. I can't say, hold on a second. Did you see what I did? Were you trying to tell me and I couldn't hear you? This is a negative 5. When you subtract 5 from both sides, you get a negative 5. So a negative 5 is the lower limit for my value. Okay? So if I said y squared minus a negative 10 is equal to 5, right? If I tried a number outside, notice that negative 10 is outside my boundary. If I try a negative 10 in my equation, then I get y squared plus 10 equals 5, which means that y squared is a negative 5. Wait a minute, you say? Y squared cannot be negative. That's why negative 10 is outside my domain. The smallest number I can put in for x is a negative 5. If I put in a negative 5, it's okay, because y minus a negative 5 becomes y plus 5 equals 5, and that's okay because that means y is equal to 0, and that's okay. That should actually be y squared. Y squared is equal to 0, that's okay. But y squared cannot be a negative number, so negative 5 is my boundary. To find domain and range, you just have to think and practice and be wise. We will talk about that some more. Domain and range is that's not the last time you'll see it, but we need to be somewhat familiar with it coming in. And then here's the thing to realize for this. This is not a function. We can tell by looking, because the y value, because the y is squared, basically. Since y squared it's not a function. All right, let's talk about how we know that. Here's another great definition for a function. When you have a function, every number in your domain goes to exactly one number in your range. We always draw a picture that looks kind of like this. Okay? Every number in your domain goes exactly one number in your range. If there's ever an x that goes to two numbers in your range, that's no good. Okay? That cannot be. And so what happens with this equation, let's say that x is positive 4. So I have y squared minus 4 equals 5. Y squared equals 9. That means that y could be 3 or y could be a negative 3. So if you have one number in your domain, you get two options in your range. Why did I get two options? Because y is squared. So, oops, not that one. Sorry. So, since y is squared, it's not a function, and the instruction said if you can write it as a function, then use it using f of x terminology, but since it's not a function, you cannot do f of x. It doesn't exist. You can't write that terminology because it is not a function. All right. Number 27, you'll find very easy, I hope. The equation is x plus 2 squared plus y squared equals 25. We've talked about this, right? It's a definition. It's the equation of a circle. The center is negative 2, 0. The radius is 5. So there's my center. If the radius is 5, then it goes out here to positive 3. It goes over here to a negative 7. It's going to go up to 5 and down to 5. And that sort of kind of, if you squint a little bit, will be my circle. So the domain, the possible x values, goes from a negative 7 to a positive 3. The range goes from a negative 5 to a positive 5. And notice I'm using brackets because negative 7 is a number in the domain, as is 3. Positive 5 is in the range, and negative 5 is. It is absolutely not a function because, of course, it doesn't pass the vertical line test. So we don't have to do part B on number 27 because it's not a function. Last problem, number 28. We're given the equation x squared minus 2y equals 3. It's okay to square the x. It's not okay to square the y and have a function. I've got to think about the domain. I've got to think about the range. I would say to solve for y like this, you're going to do that for the function part anyway. If we know that y is equal to x squared minus 3 over 2, again, x can be anything. But y cannot be anything because y has, at the smallest number there, could be 0. So y could be 0 minus 3 over 2. That's a negative 3 halves. The question is that the biggest or the smallest that y could be? That's a boundary. Okay, let's try and see. Another value for x, what if x is 5? This is when x is equal to 0. That's the smallest that x squared could be. If I let x be 5, then I'm going to have 25 minus 3 over 2, which is 22 over 2, which is a positive 11. So if negative 3 halves is a boundary, and y could also be 11, then that tells me that negative 3 halves is this small boundary, and it doesn't go up to 11, it goes up to infinity. It's going to go on forever. It's going to get bigger and bigger and bigger. Okay, and that is my equation, or my domain and range. I've actually already found the function. I did that here to help me find the range value. And if you put in a -2 to this equation, you get 1/2. And so, so that's the final answer to these equations. All right, domain and range, completing the square and circles. There really are some somewhat new things here, but those are things that you can work through, and I think that you have seen. You just might need to practice a little more than some of the other skills that you've done more of. All right, that's the end of this recording. Thank you very much.